Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Synopsys. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead, but first I have a couple of housekeeping notes. First, today's session is being recorded, so if you happen to miss any of our session or you'd like to rewatch, the on-demand version will be made available shortly after we conclude our live webinar today. If you have any questions for Natasha, we want you to send those into the Q&A tab on the right side of your screen. And for any other comments or discussion points, I want you to go ahead and use the chat tab for those. If you navigate to the handouts tab on the right side of your screen as well, you'll find a couple of links that we have included to further the materials for today's webinar. You'll also find a copy of the slides at the bottom of the list. Finally, at the conclusion of our webinar, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic today is top 3 ways to build security into DevOps. And I'm joined today by Natasha Gupta, Senior Product Marketing Manager at Synopsys. Natasha, thank you so much for being here with me. I will turn the floor over to you.
Thank you. Thank you, Cody, for that introduction. So folks, thank you very much for joining us this morning on our session on top 3 ways to build security into DevOps. In today's session, we're going to briefly touch on some security challenges that modern software development presents us today and dive into 3 principles of building security into DevOps that are some good frameworks to keep in mind as you go about trying to implement a effective DevSecOps implementation in your organization today. A little bit about myself. I am a senior product marketing manager at Synopsys. I manage a product called Synopsys Code DX and Intelligent Orchestration, 2 products in the ASOC space, which we're going to talk to you about today. I have 9 years of experience in the cybersecurity and enterprise networking space, and I've formerly been with ServiceNow and as well as Imperva and A10 Networks in various product marketing roles. So I'm really excited to talk to all of you today about what are these principles and trends that we've been seeing in the application security space, and what are some emerging technologies that can really help tackle a very fundamental question, which is how do I not let my security program and my security apparatus get in the way of my development agility, which is very fundamental in answering as you go about building security into DevOps. But to understand the scope of that problem, let's first dive into what are some of the complexities in security that modern software development really introduces. The truth is, software design has fundamentally changed in the past 8 to 10 years or so, in that it is delivered much faster, and with many companies employing microservices, serverless architectures, these are very nimble mechanisms where you have upwards of over 1,000 builds per day sometimes for large enterprises that can be deployed to production. In fact, it's estimated that Amazon pushes a build to production once every second. Companies like Facebook produce between 50 to 60,000 builds per day of Android builds. So that is a very small set of statistics that shows us the scope at which DevOps has fundamentally changed the software delivery speed and mechanism and the scale of that issue. Because when you look at individual components and the building blocks of software today, it commonly leverages third-party and open source components. And therefore, there are multiple opportunities when you look at the span of not just custom code, but all sorts of applications that organizations rely on that leverages these different components, whether it is infrastructure software, commercial software, contracted software there, and custom code from within. There are multiple opportunities for software flaws to make it into production level code. And in fact, this is revealed in a recent statistic that it's close to about 80% of production level code that can contain known vulnerabilities and go unmitigated for these software flaws. And so that gives you a sense of what is the scale at which security vulnerabilities can be present and have to be addressed at the application level. Now, at the same time, application security has a tremendous conflict and with the current speed at which at which development groups need to be pushing production level code, in that various mechanisms of how it is implemented are really at odds with the agility introduced by DevOps. Because the truth is, there are many time intensive parts to application security. There is the time to run testing. There is the manual assertion of whether a set of results is normalized to the point of being able to present data that is accurate, and eliminating false positives, eliminating redundant results that can be found amongst multiple tools. And then the second time intensive part of that is triage, where it can take upwards of almost 10 minutes per finding for an analyst to ascertain whether to escalate that finding and locate the responsible developer groups that need to handle the remediation of that given software vulnerability, or be able to ascertain what is the right fix for that. And so these are just a few of the bottlenecks that introduce a lot of cumbersome components to how application security is really at odds with the speed of development agility that is introduced by DevOps. And so what you have as a consequence of that is that cyber criminals are very keen to exploit that particular flaw in how application security is often at odds with the speed at which DevOps and the speed at which modern software development pushes these types of exploitable flaws to production. You're seeing that cyber criminals are very keen to take advantage of these gaps. And in fact, in the last year, Forrester published a report noting that about 40% of exploits in the last year, of external attacks in the last year, were taking advantage of exploits in web applications, and about 30% of those external attacks were taking advantage of software vulnerabilities. And indeed, what organizations at large are thinking about when they look at organizational risk is also taking a very sharp look at what is the scope of that question when we talk about application risk, which is still a huge blind spot for them today. Now, when we look at what are the various components of application security testing, and a second part of this problem in how DevOps and DevSecOps programs often often have some struggles in being implemented effectively throughout the enterprise, we have to look at the individual components of what comprises an application security testing program. And the truth is that for many enterprises, they are often running multiple tools when we talk about application security testing tools. And there's a very good reason for that, which is that when you look at the multitude of application security testing tools that are employed, whether it is static application security testing, source code assessment, dynamic application security testing, or if you're taking manual pen testing, well, each of these tests for very different types of issues. For example, source code issues are best addressed by a SAST or SCA solution, and that is best employed at the build level. And as opposed to dynamic application security testing, DAST, which is best employed at a point where in simulated production conditions, where you can test for issues in code based on runtime conditions. And so each of these tools operates in their own silo, and each of them contains relevant security data that is necessary to ascertain which particular source of my software defects or issues is this issue present. And what can happen a lot of times with AppSec initiatives within organizations is that when you have siloed information like this across many different tools, you have an abundance of data that is coming in about different vulnerabilities that you may have. And oftentimes, for large scale organizations, you may have only one or two dedicated AppSec engineers for every 100 developers. These sets of problems create a huge set of bottlenecks for both stakeholders in resolving a given application security issue. It creates a tremendous bottleneck for the security analyst in being able to normalize a lot of this data and be able to figure out which are the issues that are most high priority critical work, and that should be escalated to a development team. And meantime, on the development team side, they don't necessarily have visibility into all of these tools, and these tools also don't necessarily interact with each other. So this creates a tremendous issue today when we look at just the components of application security testing. And indeed, when we did research on this with multiple organizations at Synopsys, our study with the enterprise strategy group found that at least 70% of organizations are using at least a dozen AST tools or more today. And the reason that many of these users of AST tools are employing significant amount in testing investment is because each of these tools is able to tell you different kinds of exploits. Maybe vendors are compatible with a specific type of programming language, a specific set of developer tools, and various supported integrations. And so many of these organizations have already invested a lot in trying to tackle the application security problem. And yet, nearly 50% of them are saying that security testing is slowing down their software development lifecycle. And so when we go back to the problem that we stated earlier, where many of these developer groups, in keeping up with these necessary SLAs, are choosing to forego even remediating a known vulnerability at times because of the impact that makes to developer productivity, and the lack of being able to integrate this AST tooling within their speed of operations. These present very real challenges to being able to have to achieve DevSecOps alongside DevOps and very robust operations that make sure you are able to mitigate risk at the application level. So with that challenge in mind, that we have a tremendous scaling problem with being able to integrate security at every stage of the software development lifecycle, that we have tremendous information silos with the state of where your existing AppSec investment can be. What are three principles that are good to keep in mind in developing a DevSecOps program that can actually succeed? Well, there are three fundamental concepts that this comes back to. The first is being able to secure code as fast as you write it. And what this really comes back to is incorporating your testing early on in the CI pipeline. The second is being able to run the right testing at the right time and really eliminating the redundant type of extraneous testing that may not be required, and to have an intelligent sense of how to orchestrate a lot of these different testing tools within your organization and do so with agility. The third, and probably one of the most important parts of this to make the first two meaningful, is being able to filter AppSec noise and filter that out and focus on what matters most. And importantly, what this centrally hinges on is being able to intelligently be able to take a lot of this rich application security data that you're getting and being able to prioritize, make sense of it, and prioritize critical work. And so we're going to go into a little bit of depth on each of these principles in practically what are some common tools and processes that you can use to implement this in your organization. So when we talk about securing code as fast as you write it, it's important to look at how effective your current testing tools are when we talk about testing downstream. And much of this hinges on being able to integrate testing within integrated development environments or IDEs. And there's an important aspect of being able to incorporate your testing within IDEs that can only be best addressed by a lightweight solution that can be integrated with that. And what that is if you are able early on in the developer cycle to identify known vulnerabilities, to identify open source issues early on, what you're doing at the early phase of your CI cycle is you're preventing the case where a lot of these very important flaws are able to slip through the cracks and get to production. And importantly, making sure that testing, by integrating that with IDE, does not significantly disrupt your developer operations at the ground level. And a key question when you're evaluating a testing solution that you want to incorporate is this: can my testing solution provide me remediation guidance? Because here's an important part of the developer side of instilling a security culture within a DevOps environment, especially, which is that oftentimes developers, even if they know that they have to go in and make a fix, they may not be necessarily security trained. They may not necessarily know how to make that fix, or what is the scope and severity of the particular flaw if it goes unchecked and into production. And so a very key component to look for when you are evaluating a testing solution is, can this testing solution really point out the source of that software flaw and provide some level of guidance and a framework to my development team on how to commit that fix. And that is something that is going to tremendously help in bridging that knowledge gap that you may face with what you're currently using today, while at the same time not significantly disrupting operations for the sake of testing. But effective testing is only one part of it. Once you've implemented effective sets of testing, what are your means to make sure that testing can be orchestrated effectively across the multiple tools that we explained earlier that you're going to need in implementing a robust application security program to check for all kinds of software flaws in various types of environments that you would need to effectively be able to understand the scope of your application security issues? One of the biggest ways in which you can make sure you're able to do this in a manner that is efficient and that is agile is being able to orchestrate security testing by implementing policies as code. Now, what policies as code does is, in a scripted format, in a compatible programming language with whatever tools you're using right now, whether it's a YAML file, a Python script, it's able to classify 3 areas that are very significant in being able to define the type of the specific decision to test and what type of testing is required. So these are the 3 basic categories that when you script policy as code that go into automating that decision making. The first is, what are the conditions for which I need to test? And that is specifically defined by app-specific criteria. So in other words, making a evaluation as you write your policy. What is the business criticality of the application that I am scanning? What is the risk of downtime of this application? For example, does this application handle sensitive critical data like PII data? That is an app that maybe would be subject to more rigorous testing and more regular testing than, let's say, some other app that may be handling a different level of data or function. The second is, what is the type of testing needed? Making a determination whether a SAST or SCA test is needed for a particular type of issue, or whether pen testing is needed within a certain time frame. It can codify what is the time frame for triggering a notification for that testing. So every 90 days to trigger a notification to conduct a pen test for maybe some type of critical app that you're monitoring. That is the second area that has to be defined when you define a policy. The third is, what are the conditions for triggering testing? And perhaps this is one of the most important components of composing policy as code that really take on the challenge of redundant and extraneous testing, which is defining what scope of code changes or what specific type of defects are the conditions that merit triggering an additional application security scan. And this is very important because there are multiple scenarios in which you may have a tool that may flag the application as having a change, but actually that change is minor and doesn't require an additional round of testing and additional level of cycle, additional time cycles and bottlenecks introduced into the development process, especially when we talk about SCA testing or SAS testing. These are time intensive scans to be running as you're trying to go through build and development processes. And so as much as you can minimize that redundant testing by codifying very specific thresholds, this is a very important part of being able to break down that bottleneck. And one of the other important parts of policy as code that is accomplished is that because you can codify a lot of these thresholds for whether testing should be conducted, you're also able to be able to integrate decision making within the issue tracking systems that your developers are using, within various tools that they are using within their org, and apply that policy directly to CI pipelines. And this is probably one of the biggest gaps that is addressed in being able to have a comprehensive and very coherent strategy around orchestrating that level of testing and scaling security operations. Having a continuous developer feedback loop is key to bridging that gap that we addressed earlier with developer bottlenecks and with that level of communication involved in making sure the stakeholders across security and development can operate on a consistent framework when it comes to application security. But what do we need to do to make that testing meaningful and to be able to glean actionable insight from the level of efficiency that we've input into orchestrating testing, and the ability to conduct effective testing that identifies the issues early on? Well, one of the final points here that is a very important principle to keep in mind is that once you have all of that data, you need to be able to pinpoint critical data with correlation ability. Because the truth is, you will have a glut of information coming from a variety of sources that each are going to merit a different level of scrutiny and its own nomenclature for assessing your AppSec risk. So each of these tools may have a proprietary notion of assessing how critical an issue is. For example, they have different rating metrics depending on vendor tools and depending on the level of scope with which they can be able to assess the business criticality of the application they're assessing. What is the severity of that vulnerability? What is the exploitability of it? What is the scope of the change and the fix that is required to make sure that that vulnerability is remediated? That level of differentiation, of definition of risk across different tools is what makes a correlation solution so valuable, because what it's able to do, it is able to consume results across different types of application security tools you're using, both stretching across automated tools and manual tools that you may be checking through you may be logging results through spreadsheets, etc. It is able to take all of that information, it is able to normalize that information to a common nomenclature, and also be able to eliminate redundant findings that you may have across, let's say, if you're using multiple SaaS tools, let's say if you have similar results that are popping up between a SaaS tool and a DaaS tool, and being able to correlate that level of information and being able to get one organized view of all of your application security data and create a single AppSec system of record. Now, especially when we talk about bridging the communication collaboration gap between your security teams and your development teams, and getting every stakeholder to be able to get visibility into the scope and the criticality of a given application security issue, and being able to eliminate a lot of the AppSec noise that comes from implementing application security internally. Correlation is a big part of that story when it comes to ultimately maximizing the value of your AppSec investment internally, and being able to make sure that every person who is involved in the process is able to immediately be able to view their most relevant and their most critical security work. The other aspect of correlation that is very important when we talk in a risk context is that a good correlation solution is also able to show you which of these findings translates to various compliance and regulatory standards that I would need to adhere to. For example, if you want to be able to filter for PCI compliance, or for if you want to be able to see which of my findings is violating OWASP top 10 standards. This is a very key part of how a correlation solution, a good correlation solution, can give you a certain level of intelligence to be able to ascertain from all of this data meaningfully, how do I audit my own internal software and my code to find out where am I out of compliance with various regulations I need to adhere to. And importantly, getting a lot of visibility into be able to see which tools are working well for me, which tools are not also working well for me in the sense of not being able to produce the most accurate data. So these are all components of why, to make the prior two steps matter the most, you need a good correlation solution to be able to finally make some meaningful insight out of all of the testing and level of operationalizing that you do internally with your application security apparatus in your development org. Now, what we talked about earlier with orchestrating testing and with being able to correlate those findings is a concept that Gartner coined as ASOC, Application Security Orchestration and Correlation. And really what this enables you to do is it enables you to achieve a certain level of scalability in your AppSec or operations. It enables you to achieve a common framework for accountability with a lot of the visibility a component that we addressed earlier with a correlation solution, and a high degree of efficiency. And all of these are very necessary parts of building security into DevOps. And importantly, what ASOC allows you to answer are maybe 3 or 4 very fundamental questions to figuring out whether your current application security program is meeting a certain threshold of need and effectiveness, which are 3 essential questions. When was my software tested? What was fixed? What was found? And what is the extent of my exposure and my exploitability? These are all questions that a good ASOC solution should be able to help you answer and improve your internal processes to ensure a level of auditability and mitigation of application risk. Now, all of these principles are not just relevant in being able to say, hey, we've put security in our development operations and we have accounted for that particular need from our business and from a internal sense of implementing a security culture for security's sake. There's actually a much larger impact of implementing a good, sustainable AppSec infrastructure based on the 3 principles we outlined to you, which are pretty much we can think of it in 3 areas. The first is an improvement in product quality, because the essential tenet of a good DevSecOps program is the notion that secure code is quality code. And when you're able to catch flaws early and develop better coding practices, you are better able to address a certain level of a security first mindset and a quality coding practice within your development organization. The second is being able to reduce developer friction, making it easier to implement security without breaking pipelines or process. And really what this gets to the heart of is not making security a boogeyman for the development teams and making their job easier in bridging that level of understanding and giving them the tools to be able to effectively implement security. Because the truth is, what we hear from customers is that if there are too many hurdles to implementing a framework for testing and risk mitigation at the application in our application security teams, then you pretty much don't have you pretty much forego a lot of security and quality checks along the way. And so the second part of this in reducing developer friction by making it easier to automate that level of process is really a very important component of making these changes long term. But the third and probably most critical part of all of this is that you are able to optimize your existing security investment. By implementing a model to correlate all of this data, to be able to have a common framework for visibility and communication, what you're really getting at is implementing a shared responsibility model across every stakeholder that is responsible for very crucial parts of application security across security, development, ops, compliance. And effectively, you're making the most of all of that investment you've put into application security tools. You're making the most out of the time that you're putting into sorting that data. And importantly, when you automate that decision making, when you're able to prioritize results effectively, you're also making the most of your current staffing, of your current development resources that are going to be responsible for the remediation, and of your current security resources where you will have analysts that need to be able to derive that meaningful insight out of out of all of the tooling and the current resourcing that you've allotted to your security budget. So it is very important to keep in mind that all of these principles are not just about implementing security. Ultimately, it's about optimizing a common framework and a shared responsibility model. So that's what we had today. And with that, I will open up to some questions here.
So we did receive a few questions, and we're going to start from the top. So, how can we handle pen testing issues or dynamic runtime security issues during development?
So the what one of the components of that is being able to implement a good source of tooling when it comes to being able to, as we talked about, integrate scanning that can scan at the IDE. And there are a host of available tools out there across SAS tools, SCA tools, but I think one of the most important components of that you have to come back to when assessing which tool is right for you is can it support, first of all, your common framework for being able to integrate directly with the tools and processes that you have, and being able to glean a certain level of information that takes pinpoints known vulnerabilities, that pinpoints open source defects, and that provides some context around that. And so at a high level, that is sort of a recommended framework for when you're sourcing a particular tool to be running to your question, at runtime, at the development level. That is an important aspect of that. For as we kind of talked about earlier, you have to kind of when you're sourcing a given tool, be able to make an assessment as to what particular compatibilities are involved with that. Certainly, we'd recommend you checking out the Synopsys application security webpage on our software integrity group to find out a little bit more about various criteria to search for.
Thank you. Our next question reads, when evaluating an ASOC solution, what are some must-haves to look out for?
It's important that an ASOC solution be able to give you a sense of accountability. So first of all, can it normalize all of your data to a common nomenclature, a common format, in you being able to get an intelligent or understanding across all of your tools? What are those, again, answering those three questions? When was my software tested? What was found? What was fixed? And what is the extent of my exposure and my exploitability? So that would be the first part. Is a good ASOC tool is able to provide you that level of accountability, and is able to provide that in a way that is very clear and understandable across the different stakeholders that will be using that tool, which span across your security and development teams. And it is an important way of bridging this collaboration gap that exists between the two of them. And the second important part of an ASOC tool is, can it give you, in the larger sense, a view of your organizational risk when it comes to measuring a certain level of compliance reporting? Because I think one of the most important criteria when you're evaluating an ASOC tool is it provides a very enriched set of intelligence surrounding what are specific points of when it comes to a specific developer context of the source of my coding issues, the certain recommended remediation guidance that is required for that particular defect found. What is the scope of how this all plays into a larger level of application risk? It's able to take a lot of that data and be able to and a good ASOC solution will be able to take that data and up level that to giving you an elevated level of compliance reporting. So those would be two areas that you should definitely look for when you're evaluating a good ASOC solution.
Thank you, Natasha. How can I promote a security culture across my stakeholders in development and ops?
It's important to recognize that what I touched on in the presentation is that security, as much as possible from a tools and process point of view, should be catered to your development and ops teams in addressing their pain point. Because the truth is, developers have an extremely important role to play in this entire process. They understand contextually the scope of and the dependencies of a given security change as it affects a particular application and maybe other applications or interrelated components that would be affected by committing a particular security change. And therefore, it's very important that what we described, coming back to these three principles, securing, being able to have a testing tool that can integrate well with a developer environment, having a way to orchestrate that testing so that your decision making is automated, and lastly, being able to make that the most sense of that data as possible with a robust correlation mechanism. These are all very important in instilling a certain, and maybe I would even call it enthusiasm to incorporate security within development and ops teams.
So what implications does the cybersecurity executive order have for software development?
Well, they're tremendous in that if you have seen the new NIST standards for cybersecurity that have come out, they are directly addressing, the notion of software security being very paramount in the and specifically handling defects early on. All of these standards are going to become the de facto notion for how company evaluations of commercial software are going to operate. And so, what does that mean for development teams? It means that you have to have some type of framework internally to operationalize security in a way that can be easily integrated with your process. And the cybersecurity executive order, and I'd really encourage folks to check out some of the resources that Synopsys has released on this with regards to specific recommendations we've made. But one of the major talking points that has come out of it is the notion of a software bill of materials, or an SBOM. And basically what it commands of various stakeholders is to take a critical look at all of the components of software, of all of the interrelated tools, and software you may be purchasing that are related, and being able to see whether it meets a certain standard and threshold for security compliance. And I think that one of the major talking points in response to the cybersecurity executive order that'll be relevant here is how efficiently, how effectively have organizations implemented DevSecOps, which basically gets at the fundamental crux of what the cybersecurity executive order demands, which is integrating a security-first culture within all software that is produced and procured.
Excellent. Thank you, Natasha. Our next question reads, do you have any suggestions around certified tools that can currently be integrated with majority of IDE tools like Spring Suite, Eclipse, and others across technology areas?
So I won't make a specific recommendations here, but what I will say is that evaluating a frame of tools, there is abundance of information out there on various types of particular features and flaws that a given certified tool can address. But it has to come back to, ultimately, does it answer a fundamental gap for your organization of addressing a level of lack of clarity around, number one, where are my defects? Can I solve for those defects in a manner? Can I pinpoint those defects in a manner that does not significantly disrupt current operations and build? And can I then be able, once I've identified the defect, to be able to instruct my teams internally on how to solve for it? So I think as to answer, the person who who asked this question, I think, when you're evaluating a given, a given tool, I think it's very important that when you're engaging in the POC process, that you keep this question in mind for your particular environment, and and evaluate a tool based on having kind of these three critical areas addressed.
Awesome. So this one is not much of a question, but they did say, "Thank you, Natasha. This has been the best DevSecOps overview I have ever seen."
Oh, I really appreciate that. Thank you.
Well, so we do have a few more minutes. I'm going to give away a couple of gift cards and give our audience a few more seconds to send in any questions that they might have. So quickly, this is for 4 $25 Amazon gift cards. Our winners are Bobby W., Artem D., Matthias Z, or Matthias Z, and Maureen C. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't receive an email, just check your spam folder. I'll also take this opportunity to remind everyone that this session was recorded. You'll receive an email shortly after we conclude with a link to access the recording on demand. And you can also rewatch on the DevOps website at devops.com/webinars and look in the on-demand section. So one more quick sweep, and I'm not seeing any more questions, Natasha. Do you have any parting words before we close out for today?
Sure. I would, first of all, thank you to devops.com very much for the opportunity to talk to a lot of concerned practitioners and this wonderful audience about this issue. It is something we get asked about a lot, and so I appreciate the opportunity to have a chance to come here and talk about it. I'd also like to let the audience know that we recently released a product called CodeSite. And this is our new solution that touches on basically SAST and SCA scanning. So to learn more, please visit the Synopsys Software Integrity website, and definitely check out what we have here. And I also would like to recommend that for any additional resources, if folks are interested in learning more about the cybersecurity executive order. I know that this is a very popular topic in the zeitgeist right now. So, if folks would like to get some more information about it, Synopsys has published a lot of valuable insight and recommendations on our blog concerning the cybersecurity executive order and the new NIST standards, which we are already seeing in customer conversations are becoming a very popular and very relevant concern for many big organizations today. And I'd really encourage folks to check out these resources. We've got some great insight here on ways that you can address the various and kind of distill down a lot of the information that has come out on these two topics. So I just wanted to make a note of that, and really appreciate the time, Cody, and being able to come here today and present on this topic.
Well, Natasha, thank you so much for being with us. I'd like to thank Synopsys for sponsoring today's webinar. And of course, my final thanks, as always, goes to you, our audience. We appreciate you taking the time to be with us for the entirety of today's presentation. We just ask that you take one extra moment and fill out our post-webinar survey. And we hope to see you at a future Techstrong Learning webinar. Everyone, have a great rest of your day.